Good morning, guys. Today's lesson is going to show us how we can create a box and whisker plot. Okay, so today's aim is how do we create, read, and interpret a box and whisker plot. For the do now, it says the following are the heights of some of the students in your class. Find the measures of central tendency for the data. Okay, so remember, guys, that the measures of central tendency are mean, which is the average, median, and mode. Okay, notice here on the side I've already written out the numbers. I ordered them from least to greatest because that's the first step that we need to take. Okay, for the mean or the average, we have to find the sum of all the data and then divide by the amount of numbers that we have. The sum is 488. We have 8 numbers, so we get 61 for the mean. Remember that the median is the middle number. So we have 8 numbers, 1, 2, 3, 4. And then that means that the median is going to fall in between 61 and 62. So you can find the average of those two numbers, or since they're just so close to each other, we know that this right smack in the middle is going to be 61.5. Okay, and the mode is the number that occurs most frequently, which in this case is 62. Okay, so that's what you should have gotten for the do now. Don't pay any attention to the homework complete. You don't need to complete a worksheet because there is no worksheet. Okay. Let's take a look at how to draw a box and whisker plot. So here we have these numbers here: 62, 67, 55, 60, 61, 58, 62, and 63. You want to, first step 1, order the data from least to greatest, okay, which is what I already have here on the side for you to see. Step 2, separate the data into 2 equal parts. Find the median. Okay, so what we're going to do is count 1, 2, 3, 4, 5, 6, 7, 8. We have 8 numbers. That means I'm going to have 4 numbers in the first half of the data, 4 numbers in the second half of the data. Okay? So that's step 2. Okay, separated into 2 equal parts. And then we have to find the median. The median is going to be in between these 2 numbers here. Okay? And what's that median going to be? Just like what we found out in the do now, 61.5. Okay, 61.5. The next step, step 3, is to find the median of the first half of the data. Okay, this is called Q1. Okay, the first quartile. When we find the median of the first half of the data, take a look here. We have 4 numbers in the first half. So, and again, there's 2 numbers in the middle of that. Let me pick another color here. These 2 numbers. We're going to find the median of these 2 numbers. Okay, you find the average of those 2. 58 plus 60, divide that by 2. You're going to get 59. Okay, and that's Q1. Okay, first quartile has a couple of different names. It's called the first quartile. It's called the 25th percentile. Okay, percentile. All right, and going over to then the second half of the data, do the same exact thing you just did for the first half. We're going to take the 2 middle numbers. Sometimes there's going to be just 1 number in the middle and you don't need to find the average of the 2 like we're doing here. So right in the middle of 62 and 63 is going to be 62.5. Okay, and that represents the third quartile, Q3. And let me just try to write that a little bit more neatly. And that is known as the 75th percentile. Okay, so here we have the 25th percentile and the 75th percentile. Where do you think the 50th percentile is? If you said the median, you are correct. Okay, so not only is this 61.5 the median, it's also called Q2 and 50th percentile. All right. Step 4 is identify the minimum value and the maximum value. Okay, so that here is going to be 55 is going to be the min, and 67 is going to be the max. Okay. Now let's move on to create the actual box and whisker plot. All right. So in order for us to do that, draw a number line that includes numbers from the smallest value to the highest value. Notice here, going back up, the smallest value is 55, the highest was 67. So we want to make sure we include all those numbers. It's really up to you to figure out what scale you're going to use. This example is pretty easy because we don't have that large of a spread of numbers. If you're dealing with something that's going from, let's say, 50 to 400, then you're going to have to determine, you're going to have use a different scale. Maybe you want to go up in 20s or, something like that. But here we can just go in units of 1. Okay, so the next part, this is probably the easiest part. Place a dot above the lowest value, the first quartile, the median, the third quartile, and the highest value. So the numbers that we just located in the previous slide, we're just going to put dots above the numbers on our number line. So the first dot I'm going to put above 55. Okay, then I'm going to put a dot above the first quartile, which is 59. And I'm going to try to keep them on the same level. The median is 61.5, so that's going to go in between 61 and 62. Third quartile is 62.5, so that's going to go between 62 and 63. And then the maximum value is 67, so I'm going to put a dot above 67. Okay, now the next thing I'm going to do, take a look at step number 3. It says draw a box between the dots that represent the lower and upper quartiles and draw a vertical line in the box through the point that represents the median. So what we're going to do here is create a box. This is the box part of our box and whisker. Okay, we want to create a box out of this. Okay, and then what we're going to do is extend that. These are our whiskers. We're extending them out to the maximum and to the minimum values. And that's it. That's your box and whisker plot. Okay, let's take a look at the next problem. So here's just an explanation of the different names that we have for the first quartile, second quartile, and third quartile. Okay, when the values in a set of data are listed in numerical order, the median, also known as the second quartile, separates the set into 2 equal parts. The median of the first half is called the first quartile, lower quartile, or 25th percentile. The median of the second half is called the third quartile, upper quartile, or 75th percentile. Okay. Let's take a look at the next example here. The heights in inches of 10 high school varsity basketball players are, you see it there as follows. Find the interquartile range of this data set. So now let's talk about interquartile range. Okay, we know what range is, right? You know how to find range. You take the smallest value and subtract it from the largest value. Interquartile range is similar. Okay, but instead of subtracting the smallest and the largest, we're going to subtract the first quartile from the third quartile. And before we do that, we need to make sure that we have the numbers in order from least to greatest. Okay, we're going to separate the data. It's telling us that we have 10 here, so we know that the first half of the data is going to contain 5 numbers. 1, 2, 3, 4, 5. Second half is going to contain 5. Since they're asking us to only find the interquartile range, we don't need to go through and have to state the minimum, the maximum, the median, and all that. We're just looking for the Q1 and Q3. So now here, since I have 5 numbers in the first half, this is my number in the middle. That's the first quartile. Okay, and going over to the second half of the data, 79 is my third quartile. So in order to find the interquartile range, you'll see this abbreviated as IQR. Okay, we're going to do Q3 minus Q1. Since Q3 is 79, Q1 is 72. Simply subtract that, okay, 79 minus 72, and that's equal to 7. So therefore the IQR is equal to 7. Okay, let's take a look here. Similar question. Okay, the following is a list of the individual points scored by all 12 members of the Webster High School basketball team at a recent game. Notice they're already in order from least to greatest. Find the interquartile range for this set of data. So again, you're breaking it up. Now here we have 6 numbers in the first half of the data, 6 numbers in the second half. So we have to find the average of those 2 middle numbers. The average of 3 and 4 is going to be 3.5. The average of 10 and 11 is going to be 10.5. Simply subtract those, 10.5 minus 3.5, and you get your answer of 7.5. Okay, let's take a look here. The number of songs 15 students have on their MP3 players is, and you see those numbers there. State the values of the minimum, first quartile, median, third quartile, and maximum. Using these values, construct a box and whisker plot using an appropriate scale on the line below. So I filled in the scale for you there, all right? This is a perfect example of having really a wide spread between the data. Our smallest number, our minimum, is 120. Our maximum is 452. Let me put these over here, actually. The min is 120. Okay, the max is 452. So when we create our box and whisker and we're creating our scale, we have a large spread of numbers that we have to make sure that we include. So the best way to do this would be go in units of 20. Okay, next thing we need to do is find Q1, find the median. Again, remember that's Q2, and then Q3. So if you notice, the numbers are already in order from least to greatest, which is very helpful. We have a total of 15 songs. So that means we're going to have 7 numbers in the first half of the data. 1, 2, 3, 4, 5, 6, 7. Okay, so the first half's going to go up to 260. And then we're going to have 1, 2, 3, 4, 5, 6, 7. Can count from the going backwards. Okay, this is going to be the second half of the data. 292 smack in the middle. That's going to be our median. Okay, so we know what the median is going to be now, 292. For the first quarter, it's going to be the number in the middle of the first half of the data. So 1, 2, 3, 4, 5, 6, 7. Since we have 7 numbers in the first half, it's going to be 145. Because notice once we have 145, how many numbers do we have to the left of 145? We have 1, 2, 3. And then going in the other direction, we have 3 numbers to the right. Okay, so 145 is the first quartile. And then for the third quartile, we have 407. Okay, so this is Q1 and this is Q3, 407. At this point, we have all the information that we need to create the box and whisker plot. Okay, now we're going to place dots above the numbers. Okay, notice I'm not placing the dots directly on the number line. I'm placing them above so that I have enough room to create the boxes that I need without having to write all over the numbers. Okay, so let's take a look. I'm going to put a dot above 120, a dot above 452, all the way over here. So it's about there, in between 440 and 460. Our first quartile is 145, so that's going to be close to 140. Okay, median is 292, so that's going to be almost in the middle of 280 and 300. And then our third quartile is 407, 407, so that's going to be closer to 400 than to 420. Okay, I'm going to put lines, vertical lines going through the first quartile, median, and third quartile. I'm going to connect them, making a box. And then I'm going to extend my lines which are my whiskers, out to the minimum value and maximum value. And there we have our box and whisker plot. Okay, let's take a look at the next question now.
Somebody's ready for a nap.
Okay, which set of data is represented by the box and whisker plot? So here we have, it's a multiple choice question. Okay, in order for us to figure this out, we need to identify the minimum, first quartile, median, third quartile, and maximum. Okay, so looking at, we're getting our information now we're pulling our information from the graph. Okay, we see that the minimum value is 23. The maximum value is going to be 50. First quartile is going to be 30. The median is going to be 40. And the third quartile is going to be 46. So you might want to look right now at your choices to see if there's anything that we can eliminate. Okay, now the minimum and the maximum values are going to be the most useful at this point, because that means we can't have a number that's going to be below 23, and we can't have any numbers above 50. So looking through, we can eliminate choice B, because here we have 52. If we had 52 in our data, then that would have been the highest, that would have been the maximum number, and it's not, so we can eliminate that. Okay, if you look at the other three choices left, it becomes a little bit more difficult at this point to just eliminate. So what we would have to do is order each of the numbers from least to greatest in each of the sets. So for A, 23, 29, 30, 40, 45, 46, and 50. For choice C, we have 23, 30, 38, 39, 45, 46, and 50. And then D would be 23, 30, 39, 40, 45, 46, and 50. So now let's split up the data into our first quartile, third quartile. Okay, right away the number in the middle is going to be the median. Okay. So the median needs to be 40. So at this point then, which can we eliminate? We can eliminate C. If you said C, you are correct. We can eliminate C because the median here is 39, and that doesn't match up with our data. So now the choice is between A and D. Let's take a look and use now the Q1 and the Q3 to figure this one out. Looking at A, I can see that Q1 for this data is 29, but that's not Q1 for the overall data. It's actually equal to 30. Double check choice D. Here we have Q1. Here we have Q3. And that matches up with our information. So therefore the correct choice is D. Okay, last one. Let's take a look here. It says the box and whisker plot below represents the math test scores of 20 students. What percentage of the test scores are less than 72? So if you take a look on the box and whisker plot, 72 represents the 25th percentile. That's our Q1, okay, our first quartile. If 72 is the first quartile, okay, 25th percentile, that means that 25% of the test scores are below 72. So that's choice A, choice number 1, 25. Okay. And then just to spin that on the other side, if they were asking us what percentage of test scores were above 72, that would have been 75%. So 75% of the test scores are above 72. And that's just simply 100 minus 25. Okay. A movie theater recorded the number of tickets sold daily for a popular movie during the month of June. The box and whisker plots shown below represents the data for the number of tickets sold in hundreds. Which conclusion can be made using this plot? So we want to go and take a look through the choices. I know I have them already listed out here for you. We go through the choices and one by one check them off. So the first choice says that the second quartile is 600. Now remember that the second quartile is the mean. In this case, the mean is 400. So that's not correct. Second choice, the mean of the attendance is 400. So if you were just reading through this really quickly, you might have missed that this is saying mean. Okay, but what is 400? 400 is actually the median. Okay, we actually can't really find the mean given a box and whisker plot. Okay, that's not really what it's for. And the mean, in order for us to find the mean, what would we have to know? We'd have to know all of the numbers included in the data. We don't have that. Okay, when we're just given the box and whisker plot, there's 5 pieces of data that we have. Mean is not included with that. Remember, mean is the same as average. So here's a little tricky. 400 is the median, not the mean. I almost missed that one when I was working this out. Number 3, the range of the attendance is 300 to 600. That's not correct. The range, remember, we get from subtracting the largest value from the smallest value, okay, which in this case is 900 minus 100, and that would give us 800, okay. The number, the interquartile range would have been from 300 to 600, okay. If that said interquartile range, then it would have been correct, but it's not. It says range, which means max minus min. Last but not least, number 4, 25% of the attendance is between 300 and 400. This is the correct choice, okay, and I'll tell you why. 300 represents the first quartile, remember, 25th percentile. 400 is the median, which is also known as the 50th percentile. Okay, so if they represent the 50th and the 25th percentile, that means that 25% of the data is going to fall in between 300 and 400. Okay. What is the range of the data represented in the box and whisker plot shown below? Here again, for the regular range, we take the maximum value, subtract the minimum value from that, we get 16. Okay, last but not least, sum it up. What do we need to know to create a box and whisker plot? Okay, things we need to know: minimum value, Q1, median, Q3, and maximum value. How is a box and whisker plot useful? Box and whisker plots help us to visually see the spread of the data and helps us to represent the data using percentages. So here, it's not so much like what's the mean, okay, what's the mode. We can't get those 2 pieces of information from a box and whisker, but we do get other really useful information as far as percentiles go, okay? And that can be really helpful. Percentiles are used a lot in real life. Even when I take my son, my youngest, to the doctor would tell me, okay, so Andrew is in the, 60th percentile as far as his height goes or his weight. Or if he's in his weight is the 25th percentile, that would mean that only 25% of babies his age weigh less than him. Okay, so you'll see percentiles being used very frequently in doctor's offices, even the test scores when we take the state assessment exams. We talk about percentiles there too. So it has a lot of useful areas that we use it in. Okay, guys, I hope you found this video helpful. If you'd like, I'm still learning how to navigate through YouTube, but I think you can hit subscribe. If you subscribe, then it'll let you know when I've posted a new video. Notice that I have videos for not only you guys, but also my Algebra 2 class. So if you see videos and you're like, we never learned any of this stuff, don't worry. It's from my upperclassmen, my 11th and 12th graders, okay? Have a great day, guys. And if you need me, you know how to reach me during the office hours from 9 to 10:30, and then again from